even health. Let's say that you get access to like let's say 1 million social media text handles or tweets, right? How would you make the computer understand which is more important, which is what is also important from a business value, kind of what was the opinion among different things, what kind of languages were used, and how do you translate them? And see, these are things that you have to do in near real time. So for example, while you're speaking, there is an online text translator that almost behaves like another human interacting, right? So from a broader perspective, NLP covers all these domains. And from a computer science background, you will look at in terms of programming using certain packages. From a machine learning aspect, you look at what is the neural network that we need to put in place, what are the sparsity metrics and other BERT things that we need to put in place. From a linguistics perspective, there are multiple analysis from a language access, right? Some of them would say what is the phonetics of the word that is being said, what is the meaning of what it is, right? What is the syntax of it, is the grammar correct? And but those kind of things, the grammar and the other ones will be very important in terms of text, in terms of books and structured text. But in terms of social media and other cases where we don't usually really use grammar, right? In WhatsApp, we will not be doing any, grammar based texting, right? So the way you apply it will be different. From a concept perspective, that actually covers, the entire subset of what NLP is all about. Now, the next part we will look into is, see, today there are multiple domain applications across sectors, right? So healthcare uses it, customer support services uses it. You have digital assistants, personal assistants that are inbuilt into either Cortana or Siri or Alexa, which kind of does some of the action figured based on your commands, right? In even TVs today can respond to commands either by using vision to speech or speech to an action, right? And the I try to summarize a lot of them, but I think we'll go into examples. So virtual assistants, you would have heard them. Most of it is all about Alexa, Cortana, or what do you call it, Siri, right? In general, speech recognition is something very common, especially for language translation or understanding what the humans are speaking about, and even deriving sentiment out of the tone, right? By just listening to some speeches. Some of these are already already done. For example, if you are using music on a regular basis, they know that what kind of mood that you're looking at that point of time based on the music you listen to, right? And then the sentiment analysis is the most common one, especially in terms of products across multiple segments, both retail, movies and the entertainment industry in general, right? So the sentiment analysis is a little simpler to do in the text, but however, if you want to build custom, sentiment analyzer for certain words, it's a little tricky. So today they can actually give you, depending on what text you provide, they can tell the mood of the tone of the text, what they intend to talk about. So that's very commonly used, especially when the customer, previews of how they understand your product, what kind of feedback they have in your product. And imagine doing that like a large world
Ganesh,
scale level, right?
Ganesh.
Yep.
Just
Right.
a minute, Ganesh. Sorry to disturb you in between. Can you change to the slide share?
Share.
Yeah.
Okay, share here meaning I'm sharing the screen. I mean to say share this slide.
Yeah,
Okay.
in the slide share mode.
Okay, you mean the PPT mode.
Yeah, PPT. Yeah. Full screen.
Okay. Is this good?
Fine. Thank you. Please continue.
Yep. Sure.
Sorry.
No issues. Okay, so that's sentiment analysis. See, there are other things today, especially in healthcare domains and research mining, right? So today, if you want to summarize, a number of records. So, for example, let's say you are trying to analyze all health records across India, right? For a given citizen, they might have access to multiple hospitals. They might have their names written differently. They might unique IDs might be different in some places. The patient ID might be different in some places, and it also helps in kind of linking them together. In general, for example, if you have 4 TB of documents, you cannot actually have a human kind of go through it. the scale of how this text analysis or NLP will help in terms of extracting all this information and try to summarize what they are talking about, right? And the linking multiple languages. Today, it's very common because you might have your own native language. The other person might not have the same native language, but in then general, how do you kind of allow that person to search based on his native language search to point to a particular thing that is kind of closely related to it. So that's a big area, especially in terms of multilingual NLP models, and especially for example the interpretation, right? So for example, if you, let's say you're searching for sitting in some rural space and then you're looking for some farming information, right? But you might be searching it in your own language, and then how do you kind of find the information in your search engines, especially for information retrieval, to find a similar one and also suggest that as a kind of close related based on the text, right, between two different languages. And then text mining is the most common one you will see, especially in social media, analyzing and looking for what people are talking about. And search engines is another common place that you will use NLP, especially kind of predicting what the next keyword is going to be or what they're going to be searching about. And chatbots is something that you would see today. Every single website today, especially insurance or any other ordering systems, retail customer interactions, right, are all dealt with chatbots. So all they basically look at is your basic text, and then they kind of respond to it based on just keywords, and then kind of get you to a resolution just automatically. So that's something that you see common today. So the other things that commonly apply to all the sectors. So for example, in any sector for that matter, right? Okay. See, the knowledge mining text classification is all somewhat applied to some of these, but also is like a concept within NLP, right? So text classification, for example, when you're looking at a student, or not even a student, let's say a patient, a health analysis or diagnosis, right? So there might be multiple diseases versus a single, issue. So the labels of how they categorize it is where the text label, similar to how we do the spam classification, where spam versus non-spam, maybe spam kind of thing. And then knowledge mining is especially when you look at research documentation, right? How do you kind of find out with all those articles out there, right? So many papers, what you're exactly looking for, what real knowledge that that particular group of articles in a domain is talking about. So those are all easy to mine using NLP techniques. Language reduction is a very common use. So for example, the moment there are some R packages, you look at, give it the text. For example, you take a website information or a web page scraping, or you look at the book and then try to supply that information. It can actually detect the information, the language direction, and also it can give you the ratio of mixing. So for example, in a given text, right, you will never have the single language. There might be English, there might be other regional languages, there might be other international languages. So all these can be kind of measured as a ratio also. Hey, this document corpus contains 50% English, 20% French, 30% Hindi, something like that you can bring out, right? So those are all, that's also used. Key phrase detection is something similar to NER, but here the thing is about to find out what exactly they are talking about. For example, let's say you are scanning 100 documents, right? 100 documents from different people. What really is common across these 100 different documents, right? Without reading them. I mean, when you read it, you will understand. But to make the computer kind of give you the key phrase, that is being discussed, or example in terms of what topics are being discussed. So that's another thing that a common application that what we commonly see, right? So now this is a kind of a very generic workflow in general for text and NLP, right? So NLP is basically anything that you deal with this after. So for example, analysis and advanced. But in general, all text, anything that you deal with NLP has to go through these first three steps, right? I mean, you'll have to figure out where your inputs are coming from. It can be just a speech, a speech audio, or it can be just a bunch of files, or it can be pages, or it can be a vision to some interpretation that you want to build in as labels and then feed it in, right? And then what we actually do is the basic text analytics techniques are just the pre-processing and data weighting, right? So the main concept you will also see is how do you parse the tokens? How do you parse into phrases? How do you parse it into sentences? And then since the word can have multiple derivatives. So for example, give, gave, giving. There'll be the give can be used in multiple ways. But stemming and lemmatization gives you that concept of the root word, which you can actually use to kind of find out a common sentiment across, just to kind of it's one of the techniques that we use. And then from data weighting perspective, right, in a given collection of documents, we call it the document term matrix, the token list, or term frequency versus inverse document frequency. We'll deal with this a little later, what it means. But in general, what it talks about is, let's say you have 100 documents. In 100 documents, what are the most commonly used words and how they were actually present across? So I'll just quickly show an example of the document term matrix. So you can look at this one. So these are 10 documents I have, right? For example, 1, 2, 3, 4, 5. I mean, these are all files that I have put the content on. And you can see the terms, right? The terms and their counts. So basically, that's how we kind of look at how the spread of words are present across the documents, and then we can use this as an input into a sparse matrix or a graph, or even to a neural network to figure out what we want to extract out of that. So that's something we will look at how to do it in R. And in analysis perspective, right, we will deal with either a dictionary lookup method for especially sentiments, or an NER detection in general. And from supervised and unsupervised, the most common ones you will look at is topic modeling, like for example LDA method. And the text statistics and topic modeling is another concept. So for example, if you're web scraping, if you want to know what they really talked about, or let's say that you take up the information of all the world leaders' speeches, and then over a period of the next, over the last 10 decades, or last decade, how much they have talked about, right? Or what they have really talked about, what were the key words, what topics were their most key speeches, right? So those kind of analysis is very simple to do in R. And then the other techniques that we'll use at we convert word into vectors, just kind of positioning them into a higher dimensional space, and then we will do either a PCA, a pulse component analysis, to kind of reduce the dimensionality, and try to do especially translation and other near real time prediction or activities. So that's something it's a little more advanced. And see, NER today you can actually use already existing NER functions to kind of look at organizations or names and stuff like that. But if you want to build something custom, right, it'll be a little tricky for you. You'll have to kind of figure out how will you kind of go about finding your entity. What is the keyword? Do we use the dictionary based method or a rule based method, etc. BERT is another very common thing that is used. See, the other concept that we actually look at, right, especially in terms of multilingual translations to derive meaning out of it. So today, if I give you a word in one language, and you can convert it into your native language just like that. But to derive the actual meaning, like the semantics out of it, just to see what is the intent of that word, what they are really looking for, is it information available in some other language, and how do we provide that in near real time to a particular user or consumer, right? So that's the generic workflow. Let me stop here for any questions before we go into any questions here so far. Any questions so far?
Participants, do you have any questions or any doubts?
Okay.
Okay.
Okay, thank you. Let's move on, right? So we will, the next two slides, we will look at what you call some basics, right? So for, you can call it acronyms, or you can call them as how do you call them as just basics, right? Just to these, you need to know all this. When somebody talks about this term in the next few topics, you should understand what they are talking about, right? So in basics of NLP, there's quite a few, and then you can actually also combine that with techniques in general, right? So what is this, what is tokenizing, etc. And then we'll deal with the R functions in general. So this is the sequence we're going to go. Now, for example, right? Let's say there is two parts here very commonly: syntactic analysis and what you call it as semantic analysis. This is very common in language term, right? So in syntactic analysis, nothing but you basically look at the grammar of the structure, grammar structure of the whatever content you're given, and then you try to derive what that is it correct? Is the part of speech correct? Is it which is the subject, which is the predicate, which is the object? So we try to derive that. As a human, it will be easier for you to do. But in NLP technique, what we use is something called a parse tree. I mean, the parse tree is nothing but you can see it on the left. It is basically we were offered water in the table, but we were not told, etc. And then you can also see John is an actor, his father is Mr. Smith. So what they are trying to do is classify a subject. I mean, parts of speech for a given sentence. So we use this just to understand who and what they are talking about, right? So tomorrow, are they talking about John? Are they talking about his profession? Are they talking about his father? And then imagine doing this at multiple sentences, and then you try to derive a meaning out of it using a higher dimensional space. That's the usual start of what we do. Why we need parts of speech analysis and syntactic analysis, right? But usually it's quite easy to do. It's not that complicated. I'm just showing you a representation of how a subject versus object versus predicate, and how that is represented. So semantic analysis meaning is basically what is the meaning of what they are being said, right? For example, is the tone or the intent is being sarcastic versus what is the actual meaning of it? Because semantic analysis is something casually when you talk about, hey, how is the weather today, right? Are you doing good, right? Are you doing good is actually, I mean, syntactically correct, but what is the meaning of it? Are you doing good means what, right? But a computer cannot understand that kind of semantics. So then it has to derive a meaning out of that sentence, what it is given to you. It's a little tricky, especially with NLP itself. Even till today, there is a lot of research going on to find the intent or meaning behind what is being said. But to understand the semantic analysis here is just meaning the meaning of what is the actual text that is being said and what is being conveyed. Because when a human to human interaction is very easy to understand. For example, a student telling a teacher or a teacher telling a student, you'll be able to interpret it. But from a computer wise, it's not that easier to do. The other thing, what you'll do, what you will hear about is called lexical analysis. But lexical analysis is nothing but splitting. What do you mean by lexicon, right? You will kind of split that into tokens, phrases, sentences. So that's what actually means, and you'll be doing some of these in your text just to understand what is the most common ones used and other things, right? So lexical analysis you'll be seeing stemming, tokenization, etc. So the morphological analysis I'm not going to cover much. It's a little more of how the casual intent is talked about. Phonological analysis, see, it's just basically useful, especially in translation and as well as understanding the word. But that's something, it's just as a language analysis, how the word is pronounced, how the letter is pronounced. But I'm not used to most of it in any of the NLP things that what I've kind of looked at. So the last topic is what is very interesting, right? So the discourse integration, right? So let's say that somebody is giving a speech, right? When they're giving a speech, if you take one sentence out of that speech, right, it will have some meaning, just the one sentence out of it. But actually, the whole flow of the speech kind of gives you the link, right? For example, what they were talking about earlier leads to that sentence, or what they're talking about in that sentence might lead to the next sentence. So the discourse integration is basically an interesting topic to look at in terms of what the flow of that speech from one sentence to another, how what is the relationship, how it was, right? So that's actually a very interesting topic to look at. But those are the main kind of things that we do in the first part of NLP. Now let's move on to what we do with the text itself, right? We will have multiple texts. What do we actually do when we get a text? So the text can be multiple things. So for example, you can have a file, just a file. You can have just a web page, or you can have a collection of 1 million web pages, or you can have a collection of 1 million documents. And there are some data sets available online. You should be looking at downloading. For example, one of the Panama Papers is around 40, right? So if you want to kind of analyze a broad legal text, that some kind of text that corpus, we call it a corpus, which is basically a collection of documents, right? So what the first thing we'll be doing is, in terms of the flow, right? We take the document, we kind of figure out, do we need to do token? Token is nothing but we split it by words or phrases or sentences. So you can do multiple ways. So some people, if it's a smaller one, you just split it by words and then look at it. In some cases, we'll be looking at um, splitting it by sentences, just to understand the way the sentence is written, to detect if it is the same author or is a different author being writing, right? For example, in some cases we will use something called n-grams. N-grams is nothing but if you say bigram means two words together continuously, or trigrams, three words continuously. So those kind of n-grams, what we can also split into tokens. The reason why that will be important is just to see what are the most commonly used pairs of words or phrases that is being used, right? So stemming is a simple way of doing root words. And it's very helpful when we are kind of trying to derive a meaning out of it. For example, giving, give, gave, love, lovingly, and the other words together, right? So what actually happens with stemming is that it gets you the root word. Lemmatization is a little similar, but there is a subtle difference between lemmatization and what do you call it? Stemming, right? So just give me 1 second. Water. Yeah, so let's coming back to lemmatization, right? So if you're looking at lemmatization, it gives you the common word or the common meaning, especially across multiple words which have a similar meaning, right? So for example, playing, plays, played, right? It basically means play, right? So and then am, are, is means be, right? I'm doing that. So that kind of meaning that it does. Stemming is just the root word, but you use lemmatization to kind of find the actual meaning of the word in a way. And this is what you call it as morphological analysis. So basically, you mean to say that they might use a different word, but all the meaning might be the same, right? So that's the meaning of lemmatization. See, document term matrix. So document term matrix is basically what I showed you earlier. You take all the documents you have and then try to build the matrix. Row is the document name or the document ID, and the columns are the words that is being used as terms inside those documents. So when you build this matrix, you actually know which word is the most commonly used or frequently used in terms of frequency. And you can also, this will give you a sparse matrix where the words are very sparse in terms of across the documents. These can be also used as the DTM matrix that you get. You can also use some sort of clustering, right? I mean, you can use clustering to see, hey, this part of the text is always biased towards this kind of meaning, right? So that kind of thing that you can derive. But this just DTM is just a basic. Anything you take a bunch of documents or a text, you will just split it into a DTM just to understand a collection of documents together. And the term frequency, and TF is nothing but term frequency. I think IDF is inverse document frequency. So what it actually means is, let's say the term frequency is nothing but the particular word is being present in multiple documents, right? I mean, what is the frequency of that being present in multiple documents? And IDF is basically the inverse document frequency. which basically means that, how much is kind of that is spread across the entire document collection or corpus. So that's what it actually means. So the reason why this is used, right, especially in terms of search and weighting of that word across multiple documents, are they talking about the same content across? So that is where the TF IDF will look at. Will be helpful, right? And what you call as sparse matrix is basically the one. Sparse matrix is a generic concept where only certain columns are the most values, and the rest is all kind of zero. But this is just a definition of I just put in place for you to understand, because you'll be using very commonly with DTM. And then there are the techniques like how do you reduce sparsity for a document, how do you reduce for example, reducing certain words to get the sparse thing at a higher range, sparsity at a higher range. So that's something we talked about. We'll look at. And then n-grams is basically what I talked about: a bigram, trigram. What are the two words commonly used together, or three words common? You can go all the way. N is just a number, and then it helps you kind of filter down. See, if you use a single word, sometimes you will not get that accuracy. As you go the number of words more, you'll kind of derive certain value, but you will need a lot of more computation power, especially to build a n-gram graph at the different models. So stop words is something very commonly used because stop words is nothing but what do you call it, right? So the most commonly used for the a and so every language has their own stop words. Now, in the most common used in text analytics is the first thing you will do is you'll just remove the unnecessary stop words. To get an accurate term frequency versus non-term or IDF frequency, right? For example, the will be used in all the documents almost in every sentence in a way, right? So those kind of things that we use, and stop words by languages vary. You can do for all the languages today. And you can even create your own custom stop words to be removed. It's a little simple to do it. So the reason why I went through it, so this is the basic cleanup that you do. Then you will figure out how do you actually understand analysis, right? So for example, DTM or the TF-IDF, you will try to understand. And then you use the n-grams to say, hey, what are the other things? This is more of analysis. The rest of them are just cleanup or pre-processing. But this one is just more of analysis. How do you interpret the results, right? Now we'll look at some code. We'll see. Let me do a time check. 20 minutes. So far, any questions? We will look at some of these techniques or codes. I'm just trying to show some example.
Is there any questions? Okay. You proceed, Ganesh.
Okay, so let's do one thing. Let me finish the slides, right?
That would be
we're at
better.
40 minutes. So let's do another. I think it will take another 20 minutes or something like that, just to go through the whole one. Then we will go into each of the slides where we have some code, and then we'll try to run that particular function. So for example, what I've done is these are cleanups, right? So for example, this is just transforming the entire content or document corpus into lawyer, and then this is just to remove the unnecessary punctuations and stuff like that. This is removing your stop words. And then if you want to look at what all the stop words are there within a particular language, you can actually do this to print. You can do any language you want. And then this is basically a tokenizer, but I made sure that it converted into a stemmer, right? So I'm just giving a parameter saying, hey, stem anything that is inside this text using the language English, and give me the words, stemmed words. So that's something you will see. And then tokenizing is basically, it's just a text where you will actually by words or stems, right? So that's something you'll do. And then the n-grams is where I was talking about. The n-grams is basically how many you want, what is the minimum by gram, and stuff like that. We'll deal with that. So let's go through it, and then probably we'll come back to this a little later. So, okay, so let's did I miss anything else? So tokens, these are all multiple functions. This is the document metrics. We'll see that in code, so that will be easier for you to go back and experiment. Okay, so the see again now so far whatever we deal with earlier is basically what we do with the text, prepare and analyze what is the text in general, right? What is there inside the text. Now, in terms of the next steps, right, is sentiment analysis. So what do we actually do with sentiment analysis, right? The sentiment analysis, the most common ones that what we deal with is in terms of what is the word and the emotion attached to it. Now, the first thing in a sentiment analysis, I mean, a basic off-the-shelf sentiment analysis is basically has a dictionary, and then it has a bunch of words, and that words are having an emotion score attached to it. For example, happy, joy, angry, sad, and stuff like that, right? So when you look at a given text, we look at there are at least two or three text analyzers. I mean there are multiple sentiment dictionary. So one will be based on Bing. There is another one called NRC. There is called APing. So then what we'll do is we'll take the existing text, join it with that, the sentiment analysis dictionary. And then once you do a join, then you'll have a score for each of those, emotions. So from there, you will kind of derive from the text, hey, this particular text is dealing with, happiness, or is this particular word is being, used for sadness. So in a given document, you can see that if the article is, positive, negative, joyful, happy, sad, etc. And there are other things that people have done just to look at for political parties, right? So they look at the text, they try to derive to see is this person a right wing versus a left wing versus in a middle path, right? And then they also can see, what kind of text is being triggered, across different social graphs or social groups. So you can, kind of look at and say, hey, this particular social graph is always negative discussions, or in this particular social graph, there is always happy discussions, or, this kind of political discussion. So that's how powerful that is. You can actually derive a lot of meaning out of it just by looking at free social media text. The semantic analysis I already explained, just trying to find the meaning. I think we talked about the actual method. I think we'll use lemmatization to look at it. Parts of speech is something that we'll use, especially in terms of translation, just to understand subject, object, predicate. And then from there, how would you derive? Imagine, you're trying to translate, something in English to, let's say, another language like German, French, or Tamil or Hindi, right? And then you also have another completely different languages which have a way to differently write, and there is no spaces in some cases. For example, Chinese or Japanese, right? The grammar is completely different between those two parts of speech. But even today, you have a lot more accurate translation. If you take any content, you try to do an online translation, you'll get a near real time accurate, for most of the languages. So that's where the parts of speech analysis comes. And how do you derive that dynamically, right? It's not like you just find the parts of speech, then you'll try to put a parse tree like what I showed here, right? So this is basically how you do a parse tree. And then you have to find a similar one on the other side with another language, and then try to map it with the scope, right? So that's where you can do a near real-time translation between languages. So the named entity recognition is very commonly used, which basically means that entity is nothing here like a person, a time, or an event, or organization, or is it a political entity kind of thing. So what is being said in that document? So for example, let's say you are saying every day you're going to web scrap the morning newspaper out of the web, and then you're going to analyze what and who they are talking about, right? So the NER will help you in that. Hey, this particular organization is being talked the most today. Maybe there is a stock impact. So that kind of stock trading algorithms are also in place, and you can combine this with other things. For example, what is the sentiment of the discussion with that particular entity? in that discussion on what was it before, right, and after. So you can actually see an infinite possibility of combining some of these to have derive business value out of it. So far, we talked about people, meaning, and stuff like that, right? So how do you know in a given 100 documents, right? Even if you find 15 names, so for example, you can have some celebrity names, you can have some political party names or political person names, right? How do you derive a relationship out of it, right? I mean, what are they talking about the same thing, or they are, is there any relationship between this content in a particular document, right? Even in a book, are there any relationship between two different characters in a book? So when you apply that, we take the entity and then try to do a relationship graph, right? Basically, you will take the entity, you will see what is the weightage of what is the discussion, and then, for example, they might be associated with a monetary value or an event of time, and then you try to do that across different entities and try to connect them together. So you will actually know whether there were any discussions which is related to that. So that way you actually see the real intent of that word or documentation. So word to vector is something we talked about. The word, you basically map each word into a vector, and you can put it in a higher dimensional graph. Then you will do a PCA analysis, and then you can do a lot more other weightage or translation and other stuff with the word to vector concept. That's something you need to know when you actually do it, but that's something is very commonly used today. And graphs, we will see an example of n-gram graphs, or what I have for a particular book. um, in terms of neural nets, there is a lot of even CNN models are used, RNN models are being used, especially for searches and information retrievals, etc., and translation. But I'm not going to cover much of that today. I'm not an expert in that. But topic modeling is something we look at. LDA method. We look at if we can run a sample today, just to take a bunch of documents and run to see what topics they were talking about. And again, see, all these are already, most of that is in Word, most of that is in R. But again, when you decide to customize it, you will need a little more work. You will need a little more research and analysis. So whatever I'm presenting today is just an introduction. That means that you can take all these functions, put it in a file, you give your input file, or document corpus. You will kind of derive everything out of this just by using the basic functions. However, if you need to customize it, or kind of build accuracy or derive some other customization, you will need to kind of do research on that a little more, and then you'll be more successful after that. So what I talked about in terms of the functions, right? So the R functions is what I used. You can use any language. For example, some people are comfortable with Python. So if you're using Python, use NLTK. The only difference is the function names might be different, but the concept, what is being applied in terms of pre-processing, cleanup, analysis, like term frequency or document frequencies, is the same. So there is no different thing from that. Now, sentiments thing, right? So this is basically, when you look at sentiments, you can have 3 or 4 dictionaries that's already there. I put Bing. There is also NRC and Affin and all the other stuff. We'll take this and then we'll join it with one of the text I have, and then see what is the value out of that. And the other one we actually look at in terms of annotation. You can look at that just to see if there is a name of a person or a location or organization that is being mentioned. Document term matrix is something we already talked about. LDA is where I was talking about topic modeling. So this is a particular function that you'll use. I think it's called latent richlet algorithm or something like that, LDA. And then you will look at what are the topics for a given text, what topics are being discussed internally, and it will give you a score for each of the topics. So then you can know what they're actually really talking about. Tokens, again, this is a bigram example. You can convert into whatever you want, bigram, trigram, etc. And this is just a graph that we need to draw from one of those bigrams. We will see this is just a sample application. So if you put all these in a sequence, including the ones earlier, you will be kind of able to kind of do the cleanup in one place, and then you kind of derive the analysis and value out of that in the other one. So let's look at the NER, right? I mean, named entity resolution. This is very common in NLP. So there are three methods. Three basic ways they do it. In terms of NER models, right? So first thing is they have an existing dictionary based, which they either use an existing one or a new one. So for example, if you are doing for a healthcare, so healthcare, there might be already dictionaries, but let's say you are doing it for a particular disease of some sort, then you will need to kind of create your own custom library or a dictionary with the words. For example, the medical terms that you're looking for in a text. For example, the symptom versus medicine that is supplied, or whatever was the dosage, etc. Right. So there is some unique thing for healthcare, right? And then you kind of use that as a way to analyze the text. So whenever somebody gives you a prescription or a file, a patient file with that information, when you look at those words, you'll be able to relate, okay, this person is mostly associated with this particular disease and this is the diagnosis, and is he improving or not based on the healthcare. And you can link similar patients across different documentations, right? So that's something where your NER entity linking will help. But so entity here, right, basically means that an object or a person or a people or organization, and even time for that matter, right? There are multiple entities. So first thing you have to be able to identify is what is the entity in the document, and then you kind of list them out separately. Hey, this is talking about people, this is talking about places, this is talking about celebrities, this is talking about a political event, or this is talking about a political person, something like that, right? So that's something you have to first identify. But once you identify, it is just like word count, right? You know that they've been talking about a president or prime minister in that document. But what are they linking that within that document? So that is where you look at all this, resolution. So the presence of the entity along with the linking, and as well as a co-reference, what they're being referenced across. So maybe somebody made a decision, which created something else, right? So that's the inference that what we need to bring. So it's kind of works hand in hand. And the most common usage that what you see today, right? For example, customer supports, right? Every day they get like hundreds of calls per customer support executive. So how do you actually know what really customer is talking about? So you cannot scale. Let's say that you have 1,000 customer support executives, and let's say each of them get 100 or 200 calls a day. That's like almost how much? 200 calls into 1,000, right? That's 2 lakh calls that you have to infer, right? Every day. Now that means in 2 lakh calls, nobody can go back and read it. You need to have a separate team just to scan this whole thing, right? Read and understand. So that's where you will actually look at what this customer or who the customer who talked about, what is the thing that he talked about, and then combine this with the other sentiment analysis. You can actually start preventing customers from leaving you, or kind of providing them a kind of correct resolution queue based on their text or a chatbot information that they provide, right? So that's the one common use we have seen. The healthcare is another common one that you will see today, because especially with specific terms or a content they have, right? It's very unique. For example, medicine versus the symptoms of the disease versus symptoms of the patient. And then you also have the age category and the other demography, right? You have to extract that out and link them together. So for example, I might be in one place working. I might have gone to a hospital there, right? And I've been, it might be another place where my hometown is, and then I'll be kind of doing some other, let's say I visited for some consultation, some other hospital. Now, at the top, right, at the top layer, when somebody is looking at this data, they need to be able to cross-link that it's the same entity, right? It cannot be duplicate, or it cannot be, and it's the same person, right? When you gather this corpus of documents across India, for example, across all the hospitals that they are giving you that information, you will be able to find the common, the persons, and eradicate duplicates much faster, especially when you're centralizing some things, right? Even for student databases, for example, right? A student enrolled in one course, or maybe has a certain differentiation in some other place, and then if the data is not structured, so for example, you might use patient ID, but there might be some other information missing, right? So that kind of centralization, collaboration can consolidation, NER can be helpful. And even also when you're doing research text mining, right? Especially when you're looking at what are the next 10 years somebody is doing research on, what kind of reference that has been already made in the past to certain topics. So this is where you'll be able to kind of build your own custom dictionary or custom rule to then pull out all the research scholar article and look at if there is anything in the past that is similar. I mean, instead of you going through imagine 100 papers, this can be done just like you can write probably in a 100 lines of code, right? So that's something that is being done. Document analysis is very common. For example, when they are comparing multiple data entries in different documents, especially today, people are scanning records for existing manual documents like bills or healthcare records and putting it as PDFs. So how do you derive that? Find that this is the same entity, and how do you link them together, or how do you kind of merge them together is something that we look at. And as I said, there are three models. One is a dictionary-based one, like a custom healthcare dictionary thing, and then there is a rule-based one, which basically you say, hey, if this is seen, then this is what they are talking about. Or or if it's an ML or DL based, you'll put one of the unsupervised or supervised models to look at the entity, and then how do you resolve it, right? I think there is. I'm not dealt with. I don't think I put blocking and filtering full details, but let me just quickly see, right? Um, so the entities, the most common entities are these. So for example, organizations, quantities, monetary values are like $1 million, 30 percentage, or people's exams, or people names, company names, political or non-political, geography locations. You'll see it as GPE or something like that in your code. Then dates and times. So the way you can look at it is, for example, let's say that there is an article or speech with all these. For example, let's say President Obama announced etc. This particular law on so and so date, right? If you consider this particular document with this sentence, so the name is basically Obama, and he is a geopolitical figure. So that means it has to be a political person, and then the monetary value or a law event announcement or date and time. So that's how we'll have to do that across different entities, right? So you will actually see some examples. I'll see if I can run one of that. And there is another very common blocks. I mean, in NER we deal with something called blocks. First we need to identify what is the noun phrase, right? So basically we say, hey, this is the person being talked about, right? Or this is the person or location being talked about. And from then you will look at how do you classify that, classification in terms of what is this phrase. Is it of a quantity? Is it of a money value? Is it a percentage? Is it something else? So that kind of classification, that what we do. And then once you know these two, then you'll have to figure out, is the entity talking about the same person or is it different? For example, you might have a celebrity's name and a common man's name as the same, or you can have a player and a celebrity have the same name. So for example, a sports player has the same name as a celebrity. Then you will have to figure out how do you disambiguate that situation, right? Because they might be talking about a player record where you might be kind of interpreting it as a celebrity event or a celebrity person, right? So those kind of things that you will see in terms of blocks. So that's how the NER model works in general. There is another simple concept. I'm not going to get into that, especially in terms of blocking and filtering. Um, it's sort of using entity pairs to match, right? And how do you actually, kind of find out what is your own threshold. So for example, if it crosses a certain threshold, you can say, hey, this entity pair is associated with this, or you filter out any entity pair which is below this particular score. So that is basically another concept. But this is something I've not dealt with extensively, but this is something that you need, you can actually, look at in deeper when you're building NER models, right? It will be helpful for you if you're looking for some custom, blocking and filtering. There are quite a few research papers on it, but that's the overall context I have. So any questions so far? Otherwise, I'm almost closer to the end, so we'll look at the code in general after this. Okay, if there are no questions, let me quickly go through what it is. So these are places that you can refer, especially if you're doing research. So the first one deals with what Microsoft Research does in a broader aspect across multiple, NLP, natural language computing in general. There is a lot of good papers and case studies that we have presented. Just please look at that in general. And we also have the Emran packages that you can use for NLP. Use that if you want, along with the other existing ones you use. So this is a sample case I added. So this will be an interesting one for you to study, especially this one deals with healthcare and how the text analytics is used, especially to identify the keywords, the dosage, etc. So this will be some. I think there's a video you can actually go through that. It'll be easy for you. And these are just other packages that I have put in place just for your reference. So this paper actually deals with your blocking and filtering. This particular paper, please kind of go through that. It kind of gives you the more NER blocking and filtering methods and how they do it in a mathematical way. So it'll be useful for you to kind of get more deeper into it. That's the main one I had for in terms of text or introduction. So let's move on to code. And meanwhile, if you have any questions, please send them out. Okay. Let's look at what do we have. Any tokens? Give me a second, okay? I'm just going through this. This is what file I was running. Is it? So, okay, it'll be a little slow. No, excuse me for that. So. Okay, every time I move, this is going to be a nightmare here. Okay, so just to give you an example, let's do a walkthrough, right? So that way, this is what we ran. Okay, so this is what we ran. Okay, so in this particular code, what we are doing here is, so we're taking a bunch of documents. We will be doing a stemming part, and then from the stemming, we'll create a document term matrix, and then from there we'll keep going. There is some cleanup, lemmatization, etc., and then we'll be. I'll walk you through the code a little bit, right? So this basically there is a file which I'm using that just basically I'm kind of reading that particular file, and then what we are doing here is basically we cleaning up, right? For example, removing space or colon or replacing that is what you would see, and then from there you would see that we're removing punctuations and then convert that into space. And then usually what we do is we just convert everything to lowercase for easy processing, just to avoid any words being counted twice when there is a single change with the capitalization, right? And then removing unnecessary numbers, we just basically use that text mining map function. And this is where you saw that, right? So the stop words English will actually show you the stop words on the website. Let me go through that, show you that. Okay, this is extremely slow. So, okay, so these are the stop words in English. So that will be removed. So, for example, he would have, they, them, their, which actually kind of doesn't give you anything. I, me, myself, etc. So those are common words, and you can do it with any other languages. And I'm removing it from the input file what I read, right? So basically, the docs is where you saw on the top where I read the file, and then that's what I'm doing here. And then we are removing any unnecessary extra white spaces. We are, let's do that as stemming now, right? So let's do what is, let's run this part of the code first. Let's run this. So you'll understand the stemming difference. Okay, so now you see that it is reading this file, okay, and it is giving you some inputs, right? So basically this is where you remove the white space and this is the value. So if I print docs now, okay, no, it'll give me the same text. So basically it'll just give me this entire text. All right, there are 30 documents, and then it's one single corpus. Now let's print this. Give me a second. So this is what is there in the text, right? So this is, you can see all that is full words. There's nothing changed. Now I'm going to do a stem, right, with this function. Okay, now it is done. Okay, now let's print the same one. Okay. Can you see the difference between these two texts? Let me show you. It's not full anymore. Do you see this? It's every word has, you know, it's kind of stem to its, for example, instead of flexibility, right now it is flexible, BL, right? And then, for example, whereas you kind of stemmed into that word. So this is basically the first thing. So for example, um, how do I get that? So if you, let's compare one thing on the top, right? So okay, I think I printed the whole one, which is messy. Sorry. Okay, but what I want to point out is when you do stemming, it's just the root word, right? It's not the full word. So it's for each of the texts, each of the book, which is basically the danger within, etc. The text, it's kind of stemmed that particular content into the root word. So that's what it has done, right? Using the stemmer. Now let's do the next one. Basically, what we look at is in terms of running the document term matrix, which is another basic one we do. Okay, can you see that now? You see the document term matrix, the same 30 documents. Now the non-sparse entity and the sparsity. So this is what we talked about, right? Sometimes you'll be reducing the sparsity by removing certain words. And then probably when you're deep diving into, let's say that whatever is the least used word, let's say address, right? When you remove it, then your sparsity might improve, right? I mean, that's something you can look at, reduce in general, sparsity might reduce. And then the weightage is in terms of the term frequency, and you can see the docs, the words that is being used, and then what do you call the frequency of those words as the matrix form. So this is the 10 documents, and then from there the actual the columns are the actual words. So when you do it at a larger scale, you will need a bigger, matrix and probably a high compute system, right? So that's something here. An example here. These are, I think this is again the frequency and stuff like that. I don't want to get into this. So this is just a fun word club. We don't need this. Let me see if we can do a graph. We did this, right? We did DTM. Okay, let's do this. This is one example. Let's switch to a graph after this. And then from the graph, we look at some of the topic modeling. I think that will cover three major areas. So at least what we touched upon. Okay, why it failed. Lot is spelling. Reload it. Oh, probably that's because my plot is here. Okay, somewhere it's failing. Let me see. Okay, the palette is not. Okay, never mind. Let me look at this and then I'll figure out why this one. Okay, I'll try to fix that when I send the code out. Sorry about that. Somewhere it's failing. I want to show a graph. Okay, never mind. Let's move on to the graph, which is what you would use. Okay, so this is basically another n-gram graph, what we look at. Okay, so this is also there in the tidy text, text mining documentation. You can look at it. So basically what we look at is we'll take a book, right? I mean, which is whatever is in the book number 10 in Gutenberg download. And then we'll try to build a bigram graph, right? So bigram graph is nothing but you split the words by two words each. And then you'll find which are the most common words together. And then from there, we will try to kind of derive a meaning out of it. So let's say, see, this is kind of reading without actually fully reading the book, just to understand what I'm talking about. Give it a second. And then if you use it to a trigram or a quadgram graph, right, you will actually get a better picture in terms of what is the most commonly used phrases, what is the most common thing that their theme they're talking about, either in one of the customer support workloads or customer support tickets, or even sentiments in Twitter, etc. So what you're actually seeing now is I take the word documents and then kind of remove the stop words, and then from the stop words I then kind of create a bigram, which is basically two words each, and then from there we were trying to put it in a graph just to see if it is the same, right? I mean, what is the derived the meaning out of it? So if you look at it, oh man, why this keeps failing again? It just worked before. Okay, give me 1 second. Okay, I'm just going to close things that I'm not going to use. Save Give me 1 second, okay? Okay, don't save this. Meanwhile, is there any questions while we're pulling out this code? Sorry, still downloading something. Yes, I can. This is my network. Okay, that's good. At least it ran this time. Okay. Now, actually, you can look at the 10, the book number 10. I think it is. I think it's some religious book. So technically, you know what they are talking about, and it's the most common, derived words, and what are they mostly, talking about together. So let's change this to another book. Right? I don't know what is book number. So this is basically an n-gram graph. So basically you took it by the two words, and then we see what are the most commonly used two words. We will split this into something else. Give me a second. Okay. Come on, guys. Come on. First. Okay, you gotta be patient with my laptop. Okay, I think there are some questions in the chat. Let's see. So voice data in NLP, right? So you have to use a speech to text, right? So in that case, so for example, if you're using Keras or OpenCV, right? Not even OpenCV, Keras or someone, just to take the text, and then we'll have to plug into a model to kind of derive the text. So that's something we have to figure out, right? So voice to data to NLP, right? It depends on how you want to build the model. See, because speech is near real time, right? So you need to have a very good model to kind of even recognize that caption or whatever I'm talking about, right? So it's possible. You can use one of those, voice to text conversion, and then see if that is usable. I think right now there is recognition, speech recognition in multiple packages. Just try to use one of them, and probably they might cost you a little bit. And what are the limitations in NLP? How to ways to analyze emotions in text? What are the ways? Uh, See, just to answer, see the limitations of NLP, right? While it can, in most cases, you know what the computer knows not what you're saying. For example, if you give it a command, it actually can tell you. I mean, it knows what you're saying, but it can never interpret that meaning. I mean, it doesn't. That's one, kind of limitation today, in terms of what do you call it, the NLP limitation, right? And also it needs a lot of compute power, especially if you're dealing with large volumes of text, right? So for example, if you collect just your own Facebook data or a social media data, it'll be around 2.5 to 3 gigs per person, right? It includes for text, whatever post you have done or tweets that you have done. So the compute power that is needed is quite large, especially with the text. Especially, see, think about this, right? We talked about excuse me. We talked about this document term matrix. So let's say you have 100 documents, but in each document you have let's say 500 words, separate words, right? For example, an essay that your students wrote. Now that 500 into that, let's say 200 students, that is the row in matrix in your case. So then that the limitations of how you can do that, how do you minimize that, how do you kind of optimize it, then there will be some accuracy errors of that. So those are things that are kind of limitations in a way. Now, the analyze the emotions in text, right? So far what I have a code. I will try to show you that, right? So we what we do is we take the words and then we map the words to one of the sentiment analyzing dictionaries, right? So from there we try to proceed further in terms of what is the emotion attached to it. For example, joy means it has certain words associated with that. Then we do an inner join. So we basically join them together. What I would do is I'll send you a link which has a detailed way to do it in R and how they do it. So it'll be easier for you to use that for sentiment analyzer. Just give me some time, five minutes or something like that. I will send that to you. So right now, let me, since this worked, right? So this is another book. I don't know what is book number 11. It looks like there is only one keyword that we are talking about. So there's nothing beyond that. But the earlier one, as I showed you, let's do something else, right? Let's say 15. As you see, that there will be multiple ways to interpret the book. Now I know what the book is talking about, and then if you run a sentiment analyzer on top of this, you will actually be able to kind of see what that book is talking about. See, this book, I don't know what this is. I think this is the book. I think this is called the Moby Dick, right? So that's the book. And then I think this is talks about a whale, right? So that's the actual content they are talked about, the most common ones in that, right? So like this, then you will attach, any other, sentiment analyzer. Let me see if I have an example. Okay, I'll show you that. Give me a second. Is this something? No, this is all lemmatization example. I just wanted to show you the topic modeling for you to use. So that's one thing that everybody. So this is another package. This is basically the Quantata package. So this is just basically you have a text model, and then you measure the frequency, the top features for a given word, and then from there you'll try to derive what topics are with. So this data set is what I've used. The data set is nothing but your UK immigration data set. I think it's not, it's more of a speech or something like that when I went through it. So give me a second, let it run. So you can see these are multiple parties, okay, talking about whatever was the text, right? And then you can see what they really talked about as a welcoming nation, what they talk about immigrants walking into each of the thing, right? And then now what we have done is we taken an LDA, the function that what we talked about. Remember LDA. Give me a second. Where it is LDA? So I'm building the LDA model from here, right? And then I'm trying to derive the topics that each of them talked about, right? So there is whichever is the highest one, whichever is the lowest topic, is kind of gives you the most important one, right? So this is the highest frequency. right? The topic proportion is basically topic 9. These are the three things that everybody talked about. And then this is the other three terms that everybody talked about, right? So you can see the weightage of the ranking. And then as you see, right, as you go down, people talked about these, the most common in the text, or the political parties talked about the most common in their speeches. And then this is the, you know, least ones that we talked about. So technically they talked about the words, and then the asylum is what kind of took a beating with the other three words or whatever, right? So this is how a topic modeling works. So imagine doing this in any of the other texts. So you will be able to kind of see what they're really talking about without even reading all that text, right? So that's the power, right? What you can actually see. And I think this is the data set. You can actually, I think this is already there. Just look at that. The other one I wanted to show you is what? Let me see. This one we saw. This one we saw. Did I show you this one? Okay, so this is just an example of you know, all this same thing. Especially we talked about stemming, lemmatization, and all stop words, right? So this is using a simple stemmer. Snowball C stemmer is the one. So let's run this. This is where I wanted to actually show. So let's run this too, right? So you can see the word is text token function. Okay, let me run this. So you can see the love, lovingly, love, lovely, all that word we have put, right? And then we put a stemmer. Now, once you put the stemmer, you see that it's the same word. I mean, the root word is the same, right? I mean, but it cannot omit all this lover. This is where your lemmatization will help, right? But this is what stemming does. This is what I was trying to show you earlier in the other text. The other one I wanted to see, these are all tokenizers. See, tokenizers is nothing but like what you talked about, right? Splitting them by characters, words, what do you call it? Sentences, phrases, and stuff like that. These are all examples I wrote, but I don't know if you want to use that now. So these are things what we talked about, right? So we can actually split them by sentences, paragraphs. Rest is all. So this is again a stemming example. I don't know if we can run lemmatization. Give me a second, okay? See, you see this word, run, ran, running. Okay, this was the word we talked about. If you run stemmer for this, you will get run, run, run. No, sorry, you'll get run, ran, run, or something like that. But in lemmatization, it will give you the meaning. Everything is talking about running, so that's where the difference is in general, right? Any other things here in OpenNLP? This is annotation. This is a parse tree, but I doubt this will work. I have last 3 minutes. I don't want to take so much time. Let me quickly see if I missed anything. Give me a second, okay? We did this. By graph is what we did. So this is the LDA method we talked about, right? So this one is again another topic modeling. An example I have. This is by the book, but let's see if this works. Okay, I did. Okay, was there any other questions? Okay, let it run. Give some time. Okay, so this is the same thing. We looked at in a different way, but there's a little more visually plotted properly. You can see what topics are being discussed across, right? There is a couple of books that we looked at. This is again an example from the the topic modeling tidy text mining book. Basically, this is the link. And then you look at whatever is the book, and then what is the associated words and the topics. So technically now, if we are able to, on top of this, if you're able to do, kind of sentiment analysis, right, you'll be able to start seeing things, for example, which part of the book is positive or negative. So that's an example that you could use. I think that's the overall thing that I wanted to cover. Any other things that you want to cover, or otherwise we can wrap up the discussion. I will try to put this code in a separate place, and I'll point you to the documentation in general. This again an example from the daily text mining book. You can use that. It's a lot simplified, especially sentiment analysis is very simple to be done. And then by the books, what is the thing being discussed in general in terms of classification, right? What is the rating and the gamma rating and stuff like that. Okay, that's something all we had, right? Okay, that's all I had. If there is anything else, let me know. I'm just putting the chat for the tiny text mining, which is the basic book that you want to cover. And since there was an ask on sentiment analysis, I'll give the link and the rest can be put on there. Okay, I'm putting that in the chat. Okay, thank you everyone. If there is no other questions, I think we can wrap up the meeting. Thank you.
Participants, do you all have any questions? Any questions? Well, if in case you have any questions, you can also message me so that we'll try to get the answer from sir. And Ganesh sir, thank you so much for this wonderful session. This was really like an eye-opener for people who are starting with NLP. A perfect session for an introduction to NLP. It covered like almost like all the steps of NLP to some basic algorithms to, in fact, sentiment analysis, as you had mentioned here with all these things. So this was really wonderful, and I guess the participants would have had some good insight into what NLP is all about if they are beginners. So thank you very much for this eye-opener session, sir. So hope if people have any doubt, they will obviously contact me, and I will be forwarding the questions to you since they might not be able to think about questions right now immediately. Thank you so much, sir.
Thank you.
Thank you.
Have a good day. Have a good session.
Yeah, thank you very much, sir.
Thank you.
Yeah. And participants, the feedback link has been posted in the chat box. Kindly fill it in. It will be enabled for not more than 10 minutes from now. So ensure that you fill it in. This is supposed to be the feedback and attendance form. You're supposed to attend all the sessions without fail in order to get the certificate. Kindly ensure you fill the feedback form so that we know your attendance. Thank you. We'll again meet in the afternoon session. I'll be posting the details. The session details are already posted, as you all can see. So it starts from 1:30 to 3. You will be you'll be joining back in the same link. I'll again post as a reminder before about 10 or 15 minutes before the session. I'll be putting that in the WhatsApp group. Kindly make use of it. Thank you for being such wonderful audience. Thank you all. We'll meet in the afternoon session.